Hey guys, I'm back. I wanted to show you something I just got. Chassis is already out of the cabinet. This is a little 9-inch TV. Here's the main circuit board here. And of course, got the power supply and some of the other audio transformer, choke, and vertical transformer. We have a tuner here, a couple filter caps. This will be the back side. Antenna connects here, and your local and distance switch. Power comes in here. And the picture tube. Little 9-inch picture tube. We'll get to that here in a minute. Scoot him over there. I'll set this off to the side for a second. We'll get back to it. I'll show you the case. The top, you have vertical contrast, on and off volume, and tuner. And all the knobs. We've got fine tuning and channel selector. Just need a good cleaning. And the other three knobs, again, just a nice little cleaning. Nice little green knobs. The side, one side here, got a little bit of corrosion going on here. The handle needs a good cleaning. It'll probably still come out a little pitted even after it's shined up. Speaker grill here. This side's not too bad. And the back. And the cord's actually in good shape. It's had the plug replaced at one time. And but otherwise in good shape. This comes off the cabinet with or off the chassis with these 8 screws, which were all there. So it's not in too bad a shape. Could use a little touch up on the paint in a few spots. Now the front, right here, it's a little General Electric. That is a model 9T002. The bottom here, there's a little broken piece, but I've got it. So I'll glue that on. It just comes out just like this. So inside, this holds the picture tube in. There was only this spring and this spring. The clip here is broken off, and I don't even know where it's at. So I'll have to do something with that. I still have the clip here. So I'll have to come up with a couple more of these about this size springs. Is not a big deal. And then rig up something over here to hold it. So otherwise the picture tube wants to pull away. It kind of settles down. Now, before we get to the chassis, I took the picture tube out, got the plug unplugged off of it. The end here was the connector, or the plug on the picture tube was loose, so I was gently unplugged it. The tube took about an hour to fully waken up. But after that, it had steadily climbed in emissions, and now it is well within the green, and got excellent cutoff control at the proper voltage. So the tube tests really decent. It's a 9QP4 General Electric tube. Now, if you notice something on this tube that you don't see, so I rotate it around. Now it needs more cleaning. I haven't fully cleaned it, but there's no connector over here anywhere along the bell. for the high voltage secondary anode. Comes off the flyback. Well, that's because instead of going that route, they go through this pin 6, and that's what feeds it. It runs around 5,000 volts, so they can get by with going through a pin in the base instead of having to have something on the side here. But that presented a problem. When I first got it out, and of course had it unplugged, and I wasn't really paying that close attention on here. And of course when you're doing a test with like the CR70 or something, you connect your filaments G1, G2, and cathode. That's all. You got 5 connections. So, and of course those pins are all there. The other connection on here is focus connection. So, and the tube tested good. Well, it turned out I got to noticing this right here. There was no pin. It was still on the TV, still on the plug, along with a good sizable length of wire. Well, since the cap was loose anyway, I realized I was going to have to get in there and figure out what I was going to do, because without that high voltage being able to connect, the tube was worthless. You know, there's no way you can get the beam up to the front. So I unsoldered it, the rest of them, and pulled the cap off, got it off, and cleaned up and everything. What was left in here, down the bottom here, was about, well, I would say maybe a millimeter length of wire above the glass. It was just enough that you could see it and feel it. Probably no longer than the thickness of this, I would say. And I needed to attach a wire there and put in a new pin in here. So I spent quite a bit of time gently cleaning up what was left of the wire there, that little short piece, the magnifying glass, and going through that, and got it cleaned up, got it to take solder, and got it tinted. Then what I did was I took a piece of wire about the size of the rest of the wires that come out of the tube, cleaned it up, got it tinted, and made one little circle loop on it. That's about all I could do, and brought her down on top of there and hit her with solder, and it worked. It took. And I left the wire long enough so that I could get through the pin. The other wires, I went ahead and attached more wires on those so that you could keep the socket up here and feed the wires through. That's the only way to really do that. As far as the pin missing, I got the rest of it out of there, and then I had an old tube. I always keep a lot of the old octo tubes and other ones like that, so that, you know, that are burned out or something. This tube happened to have an open filament, and so that I could get a pin for here. Well, I went ahead and broke her down and kept breaking it down till I just had the pin alone. Then I took my needle nose pliers and slowly and gently straightened out all these bent over parts here, where it's bent over and crimped. Finally got that done, where I took once I got that out and cleaned up and got it straightened out, which took some time. These are made out of brass, so you got to be real gentle, but you can straighten them back out. I took well, I didn't want to use a drill, so what I did was I got a drill bit that would fit in there really good, and hooked it on. I took a pair of vice grips and on there so I could just do this by hand, and drilled out what was the remains of the corroded pin that was in there, left in there, which basically was, it had broke off right off the top here, and all it was left was just a little bit going through the plastic in this bottom. Got it drilled out, got this bottom straightened out, stuck her in there, and then I started off with center punch, which spread it out a little bit. And then I took this pin punch and gently tapped it back down until it was tight. And then I could feed the wire through and solder it on. Once I got the cap all glued back on and everything soldered back on, and retested the tube, everything looked good. And then I ended up taking my test ICO 950B and proceeded to hook to these, except for filament. Don't ever hook one of those even to a 6.3 volt filament winding, because it will burn them out. I left the filament alone, but I wanted to check capacitance between and leakage between all the other pins, because you can put 500 volts pretty much on there, and you can also check capacitance. See, I've got the data sheet for this. It tells me the inner electrode capacitance between all the pins, and it comes out pretty close to what the ICO is saying. When it's getting down that low, the leads, the wires themselves will give a little capacitance, so, but it's well within the ballpark. So I knew that I had no leakage, and I knew that also, at least not up to 500 volts anyway. And also knew that everybody was making contact with the inner electrodes. It's one little test you can do. That's one nice thing about tube manuals, tube data sheets. They also give you this capacitance inside here between each one of the electrodes, and you can actually use a capacitance tester and test those. This runs off a 4.7 volt filament. There's no transformer. This is a series strung set. We'll go over the schematic here in a minute. So I don't know how long this repair will last. Hopefully quite some time. But these tubes do show up every once in a while on eBay. I see a few of them a year show up there. They usually range average price around 20 bucks for them. So they're out there. So with that being said, let's move this guy out of the way. We'll look at the chassis a little bit, and we'll look at the schematic. This is going to be a long drawn out project, because if you notice, we have a nice little patina of rust. This was a barn find. It did say that in the description. I got this off eBay, and he did say it was a barn find. And he had good pictures, and I could tell from the pictures there was some other corrosion. But heck, really, from Iowa, or the Midwest anyway, or barn, wherever it was. This was actually out of Ohio, is where it was shipped from. So I would assume probably somewhere around there. Where else can you get a better, beautiful patina of rust? Only out of barns. So, obviously, we got a lot of derusting to do. So this thing's going to be completely dismantled. Now the beauty of this thing is the circuit board is wide open, for the most part. I mean, I'm going to take the yoke off because it is very unprotected, but otherwise she is quite open. What I mean by the yoke being unprotected, here's your leads going from the wires here. There's no cover goes on this. This normally sits up tight against the picture tube bell. So that's why they bothered not to put a cover on it. So I'm going to take all the leads loose. There's just 4 leads, and get it into a safe spot. But I'm going to go ahead and dismantle this thing completely. I want to get the circuit board off by itself. I've got this metal bracket here. Hopefully, with a lot of little nice time and slow process, I can untwist these twist locks that hold the controls in, which, by the way, were completely frozen, and after spraying some lubricant on them, I've got them. These up here still ain't finger yet, but they will turn with the knob on them. They still need a good lube, but they need to be cleaned up first. But I want to get them off this bracket if I can, because they're soldered directly to the board. This bracket does come off real easy. A screw here and just a spot over here where it goes through and holds in. Take it off. Take off all the other small metal parts. The worst one will be right here, which has got a lot of stuff hooked to it. Tube sockets will have to just stay on there. But take as many of the metal parts and stuff and put them in Vapor Rust so they'll clean up. And plus I can get the circuit board off. It's a lot easier. It's been worked on. Interestingly though, only 2 tubes have ever been replaced in it. The rest of the tubes are all GE tubes except for 2. They also have a date code on. This TV was built around, came out around 1957, and the date code on the tubes run from late part of 56 and very early 57. So of the GE branded tubes. So they are definitely original tubes except for 2 that I found in here. Fuse is here. I've already pulled some of the tubes out. These tube shields slide up and down, but they're pretty rusty. They have to be cleaned up. We have 5 couplets or K networks. There's one hidden way back in here. There's one here, one here, one here, and one that really is just not it. I don't know if I can actually get in there. Maybe I can try to move this over and see if I can zoom down to it, but it looks just like a little round capacitor here. It's this guy right here. There's a resistor and capacitor here. What this does is the ground plane is basically on the circuit board, but a lot of the metal parts are not grounded, so they have to clamp them. And so that's what that does. That's just a capacitor and resistor that hooks from B- to those metal supports and frames. Horizontal output tube here, and damper, and this here is our high voltage rectifier and our flyback. High voltage rectifier has no cap on it. The anode connects through the tube base, again because you're going to run about 5,000 volts, so they can get by with that. We have, since the picture tube actually has no outside coating on it, they are using a doorknob cap here for the filter, and I think it's 10,000 picofarad at 10,000 volts or something like that. The filter caps will be pretty easy to get out. They're just snapped into place. This one actually came loose from its snap, or the snap is, that just fits down in. There's no bolt or rivet, so it just came loose. So these 2 will be easy to rebuild. And of course I got to test everything and check everything out. A few other things. Let me zoom back out a little bit. A few other things I want to do is the switch. I got it moving. I'm not really worried about it. I'll probably just set it. If it's not making good contact, I'll wire it up so it's direct. But I'll probably go ahead and drill these rivets out because I'm pretty sure there's probably some rust behind there, and I probably won't be able to get it completely clean even with the Vapor Rust unless I get this plate off. It may or may not, so I may just drill those out. So speaker's in good shape. It'll come off. It just needs a little cleaning. A little stuff on here, but there's no tears in or anything. I'll probably use some Eileen's tacky glue on there. A 50-50 solution of water and Eileen's just to paint the whole thing, just to give it a little added strength. And that's about all I can say. It has been worked on. This is a replacement cap here. And all these other orange ones are all sprayed caps that's been replaced. This is the dual diode selenium. It's been replaced. Both, I can tell by the way it's soldered in there. They just cut it off the top here and then pigtailed it and put the new one in. But also looking at the pictures with Sam's, it was totally different shape. So I'll probably replace that with a couple either chalk keys or signal diodes, depending on what I got. So kind of look at the schematic here. This is what the set looks like when it's together. So and the chassis off of here, set it down. So I'm going to drop you down a little bit here, yeah, hopefully nice and gently, a little bit, and we'll try to remove one other thing here. All right. So we'll look here first. Get a pointer. And we'll zoom in a little bit. All right, we have our power supply here. Notice it's a series strung set and stuff. Oh, by the way, there's that bad pin. Hopefully that'll show up. It's corroded off. Anyway, we come in. We have a choke here. They opted to use an RF choke as opposed to using a capacitor to filter out any RF noise that may be in the power line. So I don't have a safety, or I have to worry about putting a safety cap in. It's got a regular RF choke. We go through the switch, which happens to be on the hot side, which is good. And then we go here. Now this is kind of a filter cap. I may put, that's awful large, so I may look at that and see what it's got in there. I may put something in there or take it out. I got to see if I got a safety cap that size, 10,000 picofarad. I may have a 0.01. Then we go through a 3 ohm 5 watt resistor, basically kind of soften the startup on the selenium diode, single diode, no voltage doubler or anything. With the 300 microfarad filter cap, a choke, and a 200 microfarad. This is a fairly large cap, and with the 25 ohm time constant here, resistance, they're getting somewhere around 145 volts on one side and 140 volts on the other side, which is kind of nice. You can actually see how much current actually goes through that. There's a 5 volt drop across there. There is no resistor used in the series string. Basically, the tube numbering, the tube count, and the voltage on these tubes come out to, it's going to be actually higher than 117 volts. They round the numbers off, but probably about 119 volts or so. But I'll probably go ahead. My line voltage ranges from about 118 to 125, depending on what time of day it is, depending on whether it's summer or winter and things of this nature. There's several houses, just like any town. When you're in town, they use one transformer to feed several residential properties, several houses. And so if you know, everybody's home and running power, well, it pulls that transformer down. But I'll probably put a CL90 in here. I just want something to kind of soften even more start on both the tubes and stuff. I'll probably, you know, I may put it back here by the switch or something, or, you know, before it goes through, or I may put it in this line. I haven't decided yet. But I want to drop that down to make absolutely sure. You know, or hot resistance is about 4 or 5 ohms. That should be enough to keep this thing in line, even with about 125 or 124 volts if it would happen to be that high and I plug it into the wall. So that of course is your B plus. We feed everything. We'll go through now and look at the tuner. Here's your local distance switch. You know, it just attenuates. You know, when it's in distance, it's given pretty much a strong signal going through without much attenuation. And of course, in the local, it attenuates it more. Goes through a transformer into the tuner. This is just a basic. The tuner in this is your basic phenolic switch. It's not a better tuner than that. It's just the individual phenolic switches that's in there, like you'd see in a band switch or something. So it's a pretty low price tuner. They're using a 6CE5 here for RF amp, and then a 9U8, which is a dual element tube. It's got a triode for the oscillator section and then a pentode for the mixer. So, and then that feeds in. There's only 2 video IFs. Intercarrier sound. The sound is picked off at the video output tube. But we're using 6 CB6As for the IF. A diode. A 1N 487, I believe they are. No, 1N87s. Germanium diode detector. And then we just feed that into our video output and then onto the picture tube. Again, sound gets pulled off here and runs up and through. It's 6AU6 for a sound IF, and we got a sound IF transformer here, 4.5 megahertz, and then this is the ratio detector. Part of it is also a secondary sound IF. Instead of having a tube, they're using again a couple of those diodes, 1N87s for that, and then we feed that out to volume control. And we have a 10C8, which is a dual tube. It's a triode with a beam power tube other section. So that gives our first audio preamp and then audio output. Of course, audio transformer and speaker. Off of here, from these 2 points, we're feeding back here for our sync with a sync separator, which is 12CT8, which also is connected into the video output tube. The video side of the video output tube is a beam power tube, and then they use the triode section as the sync separator. Vertical integrator circuit, and then we've got just a vertical multivibrator and output here. 1 tube for both. It's another 10C8, just like it was in the audio. A triode and a beam power tube for output. Height, linearity, and hold here. Of course, that feeds into the deflection coils, the vertical deflection coils. Come across here to our phase detector and feed in to a 7AU7, which is a dual triode for the horizontal multivibrator section for the horizontal oscillator. You can adjust the oscillator frequency here, and then it's just got horizontal hold, no linearity controls. This feeds into a 18A5 for horizontal output, a 1V2 for a high voltage rectifier, and a 17H6 for the damper tube. It's a pretty simple circuit. It's reduced down to a pretty reasonable price. This set was touted by GE as being the lightest portable out there at the time in 1957. It is pretty light. It's I'm not sure exact weight, but it's just under 13 pounds. So it's not really heavy at all. Not much weight to it. They reduce their tube count by using dual section tubes, a lot of them, like the 10 C8, the 12 CT8, 7AU7, 9U8. So, you know, you don't have to have as many tubes. The other thing that they did was made use of some germanium diodes, where otherwise you may have tubes there like a 6L5 or a 9T8 or something of this nature. So this set will take some time. There'll be a lot of videos on it, and I'm not sure exactly when I'll get started on it, but we'll be getting started on it probably fairly soon, sooner than later. And but we're going to take it nice and slow. A lot of videos on it because there's a lot of cleaning, a lot of derusting and stuff to go on this. So I hope it'll make for some interesting video, and you guys enjoy it as we go through this set and everything. So that's about all I've got. I just wanted to show that to you. Nice thing about it has all the knobs. So I wanted to talk about that picture tube and what I had to do to it and everything. I didn't get any pictures. Generally when I start getting into something this delicate surgery like this, I just get into the zone and go for it. So anyway, look forward to a lot more videos on this as I go through it and work on it and stuff. And since we are coming into spring, if I could, you know, I'll look at this cabinet and stuff, especially that one side's got some corrosion on it. I may deem to go ahead and strip it and repaint it if I can find something pretty close to matching. The sides are basically the same color as the plastic front. I may take that broken piece instead of gluing it on, take it with me and see if I can match up something for them colors. So anyway, so if we do, you know, you'll see some videos on that. So I guess I don't have really anything else to say other than in the next video I'll probably get started on the chassis first and disassembling it and going from there. So I want to thank everybody for watching. If you like the video and want to, you know, definitely want to see more, give it a big thumbs up. I want to thank all my new subscribers. I got a few more, and thank you for coming on board. There's be a lot more videos like this and on theory and everything else. So thanks for watching, guys. I'll see you guys on the next video.